Welcome viewers. In this video we'll see the problem based on the mesh analysis in equation method. The mesh analysis explanation available in previous video. The link is available in the description box. You can see that. In this video we are seeing the problem based on the mesh analysis using equation method. The question is find the loop current for the circuit given below. We need to find the loop current for this circuit. Now consider this circuit diagram, circuit network. The 10 voltage is applied this side and other side 25 voltage is applied. There are 5 resistors available, 10 ohm, 15 ohm, 25 ohm, 5 ohm and 20 ohm. So by seeing the diagram we can able to identify this is the one closed loop. It's called a loop 1. Containing 10 voltage source, 10 ohm, this 25 ohm and 5 ohm. This is called a, we can consider this is the one loop called a loop 1, first loop. The current flowing through the first loop is I1. See the current direction, this is the current direction flowing in clockwise. So this is the another loop. Loop is nothing but closed path containing this 25 voltage, 15 ohm, 25 ohm and 20 ohm. We can consider this is the second loop. It's called a loop 2. The current flowing through is I2. Flowing through the second loop is I2. So the I2 also flowing in clockwise direction. So we framed 2 loops. This is loop 1 and this is loop 2. Current flowing through loop 1 is I1. Current flowing through loop 2 is I2. Both are same direction. Our aim is to find the value of this I1 and I2. So we can apply the Kirchhoff's voltage law to the loop 1. This is equation method. So we are going to frame the equation. So we will apply the Kirchhoff's voltage law to this loop 1. What is Kirchhoff's voltage law? Potential rise equal to potential drop. So this 10 voltage source is the potential rise. The potential is given from this. What is potential drop? The drop across this 10 ohm resistor, 25 ohm and 5 ohm. These are all the voltage drop. So this potential rise is equal to sum of this potential drop. That is the statement given by Kirchhoff's voltage law. So based on that we can frame the equation. Potential rise is 10 voltage, 10 equal to. So these 3 are potential drops. What is the potential drop here? V equal to I into R. What is I here? I1. I1 is flowing through 10 ohm resistor. So 10 into I1. The potential drop V equal to I into R. I is I1, R value is 10. So 10 into I1. That is the potential drop across I1. Drop across 10 ohm resistor. What about 25 ohm resistor? This 25 ohm resistor connected between loop 1 and loop 2. Commonly available between loop 1 and loop 2. So I1 current is flowing through loop 1 and I2 current also flowing through loop 2. I1 current is flowing from downwards. I2 current flowing upwards. Both are opposite direction. So while considering this 25 ohm, I1 also flowing, I2 also flowing in opposite direction. So we need to take I1 minus I2. So while considering loop 1, it is I1 minus I2. While considering loop 2, I2 minus I1. Because we considered loop 2. So I2 minus I1. Loop 1, I1 minus I2. So 25 ohm is connected between loop 1 and 2. Both I1 and I2 current is flowing. But current direction is opposite. This current is flowing downwards. This current is flowing upwards. So the difference between these two current is flowing through the 25 ohm. So we are taking I1 minus I2. 25 into I1 minus I2. Suppose the current is same. Both current is same means I1 plus I2 we can take. But here opposite. So we are taking I1 minus I2. Then what is the potential drop across 5 ohm? Only this I1 is flowing. So I1 into 5. That is 5 into I1. Right. So this is the potential rise. This is the potential drop across 10 ohm, potential drop across 25 ohm, potential drop across 5 ohm. So equation number 1. We'll take this equation number 1. We'll simplify this equation later. First we'll take it as equation number 1. Now see the potential of this 10 volt. See that current direction, current is flowing in a clockwise direction. That is, it is flowing from downward to upward. In this 10 ohm voltage source, it is flowing downward to upward. Let's see the direction. It is flowing like this. So from negative to positive, the current is flowing from negative terminal to positive terminal. So potential rise, so that we are taken plus 10. But while considering this 25 ohm, see this, the current is flowing downwards from positive to negative. Positive terminal to negative terminal. Potential is dropped here. So minus 25. See here, this current is flowing upward, bottom to top, negative to positive. So rise of potential, 10 voltage. Here following from top to bottom, positive to negative, fall of potential. So minus 25. So flowing this downwards, positive to negative. So minus 25 volt. So this is the potential. What is the potential drop? There are 3 resistors available: 15 ohm, 25 ohm and 20 ohm. In 15 ohm only I2 is flowing. So 15 into I2. In 20 ohm also only I2 is flowing. So 20 into I2. But in 25 both I1 and I2 flowing. We already see that both are opposite. So in previous case we taken I1 minus I2. While considering loop 2 we need to take I2 minus I1. Right? So this is the potential applied. This is the potential drop across second loop. We take this equation number 2. Now we'll simplify this equation 1 and 2. Then we can go for further modification so that we can find the value of I1 and I2. Now we framed equation 1 and equation 2 from loop 1 and loop 2. Now take this equation 1. This equation 1 is taken as it is. Now we are going for simplification. So we consider the equation 1. Now we'll go for simplification. 10 equal to 10 I1. We multiply inside. 25 multiply inside. So that 25 I1 minus 25 I2 plus 5 I1. So this 25 is multiplied inside. So 10 equal to this I1 available here. 10 I1. Here 25 I1 plus 5 I1. So 10 plus 25, 35 plus 5, 40 I1. This I2 available only one time. Minus 25 I2. Right? So we can rewrite this. 40 I1 minus 25 I2 equal to 10. So it is rearranged. Right hand side and left hand side terms are rearranged. So that 40 I1 minus 25 I2 equal to 10. So we can divide by 5 so that the equation further simplified. So 40 divided by 5, 8, 25 divided by 5, 5, 10 divided by 5, 2. Now it is simplified form of equation 1 is available. Equation 1 is now simplified. 8 I1 minus 5 I2 minus 2. Take this equation number 3. Right? So step by step the equation is reduced and finally we got this equation, simplified equation. We take this equation number 3. Now consider the second equation. The second equation is written as it is. What is available second equation? Written as it is. Now we go for simplification. Minus 25 equal to 15 I2. Multiply this 25 inside. So 25 I2 minus 25 I1 plus 20 I2. Right? This 25 is multiplied. So minus 25 equal to, see this I2 available here. 15 I2, 25 I2, 20 I2. 3 times available. So 15 plus 25, 40. 40 plus 20, 60 I2. And I1 available one time. Minus 25 I1. Now we'll go for further simplification. So now the terms are rearranged. Minus 25 I1 plus 60 I2 equal to minus 25. Right hand side term is brought to left side and left side term is brought to right side. So here also we can divide by 5. So 25 divided by 5, 5. 60 divided by 5, 12. Minus 25 divided by 5, minus 5. You take this equation number 4. Right? Now the equation 2 is simplified, and finally we got this equation. Simplified equation. This takes us equation number 4. Now we got equation 3 and 4. Simplified form of equation 1 and 2. So by solving these two equations, we can find the value of I1 and I2. By solving this equation 3 and 4. How to solve this? So we can cancel any one term, either I1 or I2. Here 8 I1 available. Here 5 I1 is available. So we can multiply the equation 3 with 5, equation 4 with 8. So that here multiplied by 5, here multiplied 8, so that we'll get 40. So we can cancel the term I1. Right? So that is available here. So equation 3 is multiplied by 5, equation 4 is multiplied by 8 in order to cancel I1. So 40 I1 minus 25 I2 equal to 10. This equation 3 is multiplied with 5. Similarly, equation 4 is multiplied by 8 minus 40 I1 plus 96 I2 minus 40. Right? The equation 4 is available here. This equation 4, that is multiplied with 8. Now see this is plus 40 I1 and minus 40 I1. So by simply adding this, automatically this term got cancelled. So this term got cancelled. We can add the terms because one is positive, one is negative. So minus 25 I2 here, 96 I2 is there. So difference between these two is 71 I2. Similarly 10 here minus 40. So minus 30. Resultant will be minus 30. 71 I2 equal to minus 30. So I2 equal to minus 30 by 71. So by dividing this minus 30 by 71, it is minus 0.42 amperes. So I2 is minus 0.42 ampere. Right? Now we calculated the value of I2. By substituting this I2 in equation 3, we'll consider this equation 3. In this we can substitute this I2 value. So 8 I1 minus 5 I2 equal to 2. That is equation 3. In that we are going to substitute the value I2 equal to minus 0.42. Right? So while substituting, we'll see what will happen. So 8 I1 minus 5 into this I2 is minus 0.42, that is equal to 2. So 8 I1, you multiply both are negative, so it becomes positive. 5 into 0.42 is 2.1, that is equal to 2. So bring this 2.1 in right hand side. So 8 I1 equal to 2 minus 2.1. So 2 minus 2.1 is minus 0.1. This is more value, so minus negative. So from this I1 equal to minus 0.1 divided by 8. So that is nothing but minus 0.0125 amperes. So now we got the I1 value also. So I2 value is minus 0.42 ampere, I1 value is minus 0.0125 ampere. So in this problem, by using the mesh analysis, by equation method, we framed two equations, then it is simplified form of equation is given. By solving the equation 3 and 4, we got the value of I1 and I2. The same problem is solved by matrix method. That video available in the description box. You can see that video. The link is available in the description box. The same problem solved by matrix method. The link available in the description box. Thank you.